Hello, my name is Gina Bai, and I'm a PhD student at North Carolina State University, where I am supervised by Dr. Stoley. I'm going to present our work on how graduate computing students search when using an unfamiliar programming language. Software is often written using multiple programming languages and expects the developers to master multiple languages. When learning a new language or working in an unfamiliar language, developers often search online for information and code examples. Recent studies have shown that the knowledge of one language can interfere with learning a new language. For example, if I've already learned how to print out the sentence "Hello World" using Java and C++, and I know this is called print statement. So when I would like to learn how to print "Hello World" in JavaScript, I can just search with the query print statement in JavaScript. Similarly, if we were given a task to create a button that pops a message box with "Hello World" on it once being clicked, we can just search for "Hello World" in VBA or print statement in VBA. If that does not provide enough information to help us create the button, we can add a query how to create a button in Excel. Mission complete. But is code search always as easy as this one? How about this task in VBA? We ask participants to write a VBA program that can look up the items in the table and return the matching price of the specific items. There are data structures, such as hash table and hash map, or APIs like dictionary and regex in other languages, such as Java, that can support this functionality. We know the terminologies in Java, but are they the correct ones to use in VBA? These terminologies were actually used in the search queries by a participant in this study. This participant considers their programming skills as expert in Java and C++, and often search online when solving programming problems. We can see this participant borrowed several terminologies from Java when composing and editing queries. But in the fact, the function is called VLOOKUP in VBA. So even though developers or computing students borrow terminologies from other languages that they are familiar with, it is common that they experience the challenge, such as, I do not know how to search for it, as the task may be hard to describe, or what I searched for is not what I actually wanted, as the terminologies between languages often differ drastically. Or I have tried many reformulations, but there are not enough relevant results. Studies on code search in software engineering seek to understand how and why developers search when performing their daily work. Researchers introduce new code search tools or propose potential improvement of existing code search tools. However, only few studies focus on developers' search behavior when working with a new language. How do they learn and how do they search? In our study, we are interested in the code search behaviors of experienced programmers when working with an unfamiliar language, and we call them subsequent language learners. Google researcher Dr. Sadowski and colleagues conducted a study to explore how and why Google developers search when working on daily tasks in 15 consecutive days with a combination of logs and surveys. They also summarized the properties of developer search sessions. It is from this study that we derive our methodology. Our methodology involves logging search and browser activities and periodically surveying participants about their current tasks. We specifically ask about search success and query reformulation. This information allows us to answer the question, what are the factors that impact the success of search queries? This question is not covered in the prior study. We run our study in a lab environment, and the total duration is 90 minutes, including a quick introduction to the study and the tool that we use to collect the data. Instead of professional developers, participants in this study were graduate students in computer science, and they have diverse programming language backgrounds, which include object-oriented programming languages and scripting languages, but not VBA. The top 5 frequent languages used by these participants were Java, JavaScript, C++, C, and Python. We asked participants to complete 5 VBA tasks, and we've seen 2 of them in the previous slides. So we developed an extension in Google Chrome to collect the logs, including user IDs, search queries, and the URLs of the visited results. This extension also deploys surveys under certain triggering events. Here is the short video that demonstrates the search activities in the running example, and let's see how surveys are triggered. So we see the participant made a search with the query VBA hash map, and it triggers the context survey. We ask participants about activities they are doing and the specific question they are solving. We designed 4 surveys in total. In addition to the context survey, we have a preliminary survey, which will be triggered when finishing installation of the extension. We collect participants' technical background, such as programming experience, their intentions of code search, and the demographic information. We also designed a search tab close survey. It will be triggered when a search tab is being closed. This survey asks if the prior query solved the problem. If so, how did it help? If not, what information is missing? A survey will not be triggered if a prior survey is deployed within 1 minute, or the number of deployed surveys has reached the hourly limit, which is 10. We now see the participant is changing the query from VBA dictionary iteration to VBA hash table in Excel. This will trigger the query reformulation survey, since a potential reformulation is detected. That is, the word level length distance from the prior query is greater than or equal to 2. This survey verifies the reformulation by asking if the current query is related to the previous one, and it also asks if the prior query solved the problem. The logs allows us to find the time intervals between surveys, the time interval between clicks, and we have the total number of queries, the number of visited results, and the average number of clicks per query. Overall, the 18 participants generated over 3,500 of log entries, including 229 queries and 216 survey responses during the lab sessions. With the combination of logs and surveys, we answered 3 research questions. Why do subsequent language learners search? What does a typical search session entail? And what are the factors that impact the success of search queries? First one, why do learners search? We found that, similar to professionals, most searches that are made by the learners are associated to goals of exploring, for example, code, and designing a new feature. Additionally, learners search for example code more than anything else. Learners also search for debugging, and all participants search for exploring regardless of the familiarity to the code. Since learners often search to explore language syntax, APIs, libraries, and example code, we encourage CS educators to include short sample code when presenting or requiring use of new APIs or libraries. As for the typical search session, we also compared the learners against professionals. The results show that The learners generated more verbose queries than professionals did. The increment in words may be caused by participants' unfamiliarity with the programming language used in this study, or from the fact that they were using a general search engine, Google, which also reported to have long correlated query lengths. We observed that, on average, the learners require longer time to scan the search results, and they visited more results than professionals did for each query. Code familiarity does not mean less clicks. Additionally, as we verified if a query relates to the prior query with participants in the service, we were able to tell that only 35% of the suspected reformulations are actual reformulations, and the reformulations occur much more quickly after a previous query than searching for a new topic. We also explored the factors that impact query success, and we found that learners frequently borrow terms from languages which they are familiar with when composing queries, and queries with borrowed terms were more successful on average. This observation is further supported by a prior work that engineering and science students who had higher levels of domain knowledge retrieved more relevant documents for search questions. We observed that consulting documentation and tutorials rather than Q&A sites leads to higher search success. This is supported by prior work as well. There are several cases where natural language phrases leads to higher search success. For example, using if statement instead of the shortcut if, and spelling out the Boolean conditions from mathematical symbols to English. And we observed several cases that consulting others leads to search success. But we need more exploration with a larger set of successful and unsuccessful queries to see if some phrases lead to higher search success. And we need to study the interplay between search and the discussion in the future study. Though some metrics used in this study may not be consistent across the participants, such as the average number of click per query and the average number of query visited, since the search results and the available documents may vary due to personalized search results. We conclude the results and suggest learners to search with natural languages phrases. We encourage learners to consult official documentation and tutorials with example code rather than Q&A sites. Additionally, as term borrowing was commonly observed in search queries, we believe that an API translator that can map APIs across languages will assist learners and improve their working efficiency. I would like to end the presentation with a few interesting takeaways. First, reformulation occurs much more quickly after a previous query than searching for a new topic. Second, the word-based launch-time distance between successive queries alone may not indicate a reformulation. Third, term borrowing was commonly observed. Although it usually causes the term mismatch in the queries, the impact of term mismatch in terms of query success and reformulation is fairly neutral. Thank you for watching this presentation.